Hello everyone and welcome to a new episode. In this episode, we'll be having the general revision on geometry. And I also recommend that before you watch this video, study the geometry very well and then come and make this episode as your self-assessment. Let's start. The first type of question is to choose the correct answer. If the base length of a parallelogram is 12 centimeters and the corresponding height is 10, what is the area? We know that the area of the parallelogram is the base multiplied by the corresponding height. So 12 multiplied by 10 is 120 centimeters squared. Question 2. The area of the rhombus whose diagonal length are 6 and 8 centimeters is what? We know that the area of the rhombus is half times diagonal 1 times diagonal 2. So it's half times 6 times 8 is 24 centimeters squared. Question 3. What is the perimeter of a square whose area is 81? If the area of a square is 81 and the area of the square is side squared, so the side of the square is 9 because 9 squared is 81. But the question here is not asking you to find the side. It's asking you to find the perimeter. As long as the side is 9, the perimeter is 4 times side, which is 4 times 9 is 36. The length of the projection of a given line segment is what related to the length of the original line segment? Yes, excellent. It is less than or equal. Question 5. The triangle whose sides are 5, 12, 13 has what area? If you check this triangle, you will see that 13 squared is equal to 5 squared plus 12 squared. So this triangle is a right triangle. So the area is half times base times height, and in this triangle the base and the height are the two smaller sides. So it's half times 5 times 12. The answer is 30 centimeters squared. Let's move to another type of question, which is complete each of the following. Two triangles which have the same base and their vertices opposite to this base on a straight line parallel to the base are? Yes, excellent. They are equal in areas. Question 2. The area of the trapezium whose parallel base is 6 and 10 and the height is 5 centimeters is what? We know that the area of the trapezium is half multiplied by base 1 plus base 2 multiplied by the height. If you do your calculations, the area will be 40 centimeters squared. Question 3. The diagonals of an isosceles trapezium are equal in length. Excellent, I can hear it from here. Question 4. If AB segment is perpendicular to BC segment, then the projection of AC segment on BC straight line is? Yes, it's BC segment. Question 5. In triangle ABC, if AC squared plus AB squared is less than BC squared, then angle A is obtuse angle. Let's move on to some proof questions. Since ABCD is a rectangle as given, therefore its area is length times width, which is 10 times 3, which is 30 centimeters squared. Since it's given that AO is parallel to EB and AB is parallel to CO, therefore ABEO is a parallelogram and it's also given. Then the area of the parallelogram ABEO is equal to the area of the rectangle ABCD, which is 30 centimeters squared. As long as AB is a common base, where AB is parallel to OC, therefore the area of triangle AXO is equal to half the area of the parallelogram ABEO. And we got it before that the area of ABEO is 30, so the area of the triangle AXO is half times 30, which is 15 centimeters squared. Question 3b. The question here wants me to prove that XY segment is parallel to AD segment. Since the area of triangle ADB is equal to the area of triangle ADC, where AD is a common base and AD is parallel to CB, let's call this number 1. And also, since the area of triangle AXB is equal to the area of triangle DYC as given, we're going to call this number 2. By subtracting 2 from 1, we will get that the area of triangle ADX is equal to the area of triangle ADY, where we have AD is a common base. Therefore, XY is parallel to AD. Question 4a. Here in this question, the question wants me to prove that triangle AED is similar to triangle CEB, and also wants me to find the perimeter of triangle EBC. Let's now go and prove the first one, that the two triangles are similar. Since AD is parallel to CB as given, therefore the measure of angle A is equal to the measure of angle C as their alternate angles, and also measure of angle D equals the measure of angle B, with the same reason that they're also alternate angles. Therefore, triangle AED is similar to triangle CEB. To find the perimeter of triangle EBC, as long as the two triangles are similar, then AD over CB is equal to DE over BE is equal to AE over CE. By substituting the given sides, it's 4 over 8 equals 2 over BE, that's unknown, equals 3 over CE, that's also unknown. To find the length of BE, it's 8 times 2 over 4, which is 4 centimeters, and the length of CE is 8 times 3 over 4, which is 6 centimeters long. To find the perimeter of triangle EBC, it's 8 plus 4 plus 6, which is 18 centimeters. In question 4b, the question wants us to prove that triangle ACD is a right triangle at angle ACD. Since triangle ABC is a right triangle at point B, which is given, therefore, by Pythagoras, AC squared equals AB squared plus BC squared, which is 9 plus 16 equals 25, then AC is the square root of 25, which is 5 centimeters. If we're talking now about triangle ADC, as you can see that AD, the longest side, which is 13. So if we say that AD squared is 13 squared, which is 169, and AC squared plus CD squared is 5 squared plus 12 squared, which is also 169. So this proves that AD squared equals AC squared plus CD squared. That proves that triangle ACD is a right triangle at angle ACD. Question 5a. The question wants me here to determine the type of the angle B in triangle ABC, where AB is 7 centimeters, BC is 12 centimeters, and AC is 8 centimeters. As long as BC is the longest side, so BC squared is 12 squared, which is 144, where AC squared plus AB squared is 8 squared plus 7 squared. The result is 113. So BC squared is greater than the sum of AC squared and AB squared. So in this case, triangle ABC is obtuse triangle at angle A. If the question here is asking us to find the type of angle B, the obtuse triangle has one obtuse angle and the other two angles are acute angles. So angle B is an acute angle. Question 5b, the question here wants me to find the length of AD segment, AB segment, and AC segment. Yes, for sure, we're going to use the Euclidean theorem in here. So the AD squared is equal to BD multiplied by CD. So AD squared is, so it's equal to 1.8 multiplied by 3.2, which is 5.76. So AD is the square root of 5.76, which is 2.4 centimeters. To find the length of AB, we know that AB squared is BD multiplied by BC, which is 1.8 multiplied by BC, which is all of this, that is 5 centimeters. So it's 1.8 multiplied by 5, which is 9. So AB is the square root of 9, which is 3 centimeters long. To find AC, with the same way with the Euclidean theorem, AC squared is CD multiplied by CB, which is 3.2 multiplied by 5. The result is 16. So AC is the square root of 16, which is 4 centimeters long. By finishing question 5, we reach the end of our revision. Thank you very much, dear students. Wishing you best of luck.